All right, let's look at the homework 4.5, problem number 1. All right, so let's try to sketch the graph of this given polynomial function. All right, let's see. Since this is a polynomial function, domain of this function is going to be all real numbers. So there's the graph all the way through. All right, and let's find the x-intercepts. All right, so in order to find x-intercept, we set y equal to 0. All right, so which means that we have to set x cubed minus 18x squared plus 81x equal to 0. All right, then we can factor out the x here. So everyone seems to have x. So you have x squared minus 18x plus 81. All right, and then we can actually factor this quadratic function out. We can see that this is actually x minus 9 squared equals 0. All right, so x-intercepts are x equals 0 and also x equals 9. All right, we got that. And the y-intercept in this case is not very interesting because if you plug in 0, y is going to be 0. So x equals 0. Then of course y is equal to 0. Right? So at least we know that the graph goes through the origin. Right? Then since it's a polynomial function, there is no vertical asymptotes or horizontal asymptotes. Right? So this is pretty much all we can get out of the original function. So this is the first step, just looking at the original function y. Right? So let's look at the first derivative. So here, y prime. Right, so if you take the derivative, you get, let's see, y prime is equal to, alright, so we have a 3x squared minus, alright, so it's going to be 2 times 18, so it's going to be a 36x plus derivative of 81x is 81. Alright, then looks like everyone seems to have 3 in it, so I'm going to factor 3 out. So we have 3 out. So we have x squared minus, let's see, 12x plus 81 divided by 3 is 27. All right, then we can actually factor this out, right? So you have 3, right? We can factor this out. Let's see, we can do maybe 3 and 9. So it's going to be x minus 3 and x minus 9. Would that work? If you add them up, you have negative 12. Multiply negative 3 and negative 9 together, you're going to get 27. So it works out. So critical numbers are, we're going to get x equals 3 and x equals 9. All right. All right. So let's draw a number line here. All right. Nope, it's not straight. Here's x. All right. So I'm going to put tick marks at the 3 and 9. So you have a 3 and here's 9. And we just need to determine the sign of, say, y prime. Right? So I'm going to check some numbers. So I'm going to try x equals 0 there. Right? So when x equals 0, so this is negative 3 times negative 9. So it's going to be positive here. Right, and between 3 and 9, so I'm going to try x equals 4. All right, so 4 minus 3 is positive, 4 minus 9 is negative, so positive times negative is negative. right? And after 9, so we can try x equals 10 or something like that. And then if you put 10 here, 10 minus 9 is positive, 10 minus 3 is positive, so everything is positive. So we have that. Right? So we know that increasing, decreasing behavior would be here. We know that before 3, it's increasing. And after 3, it's decreasing. And after 9, it's increasing. Right? From there, we can make a conclusion that here, we're going to have local maximum at x equals 3. And here, we're going to have a local minimum at x equals 9. Right? So, so we have that. Right? Then maybe it might be a good idea to plug x equal 3 and x equal 9 to find the actual value. So let's do that. So y of 3 is going to be, so this is going to be the local maximum value. So you have a 3 cubed, so it's 27. Right, then you have 18 times 3 cubed, so 18 times 9. So this is going to be minus 9 times 8, 72. Right, and 9 times 1, so it's going to be 162. So 162. Right. Right, and you have a plus 81 times 3, so it's going to be 1 times 3 is 3, 3 times 8 is 24, so you have 243. Right, so this is going to be equal to, let's see, I'm going to just add these numbers up, 3 plus 7, let's see, A4 plus 2 and another one, so it's going to be 0 and 7, all right, 270 minus 162. So this is going to be 108. All right, so this is the local maximum value is 108. And at 9, we're going to have a local minimum value. So we're going to find that. So we have a y of 8. Oh, sorry, not 8, 9, sorry. 9. All right, is equal to, all right, well, what is this? Let's see. Actually, if you plug in 9, this is probably the easiest one to look at. If you plug in 9 here, 9 minus 9, so that's 0. So it's going to give you 0. Right? So local minimum value is 0. Right? So we got that. All right, then we can talk about the second derivative. So let's look at the second derivative here. So I'm going to go up here. So number 3, let's look at y double prime. Right? So we take another derivative. So y double prime is equal to 6x minus 36. Right? So we can pull out the 6, x minus 6. We set that equal to 0 to find a possible location of inflection point. So x equals 6. Right? Then we're going to do a number line here. Right? So here. And the only tick marks we have to put is at 6. Right? Then we just have to look at the sign of the second derivative. Right, so we can try x equals anything like 0. Right? Then you can see that 0 minus 36, so it's negative. So you have a concave downward. And after 6, so we can try x equals 7. And if you plug in 7, it's going to be positive. So positive here. Right? So if you look at the shape of the original function, you will see that you're going to have a concave You're going to have a concave down shape here. And after that, it's going to turn into a concave up shape. Right? So since there's a concavity change, we know that there's going to be a inflection point at this point. So here's an inflection point. All right, so let's find the inflection point there. So corresponding y coordinate would be, so y of 6. Right? I think it's easier to look at this one. So it's going to be x is 6 times, right, 6 minus 9, so it's a negative 3 and squared. Right? So it's going to be 6 times 9, so it's a 54. Right? So we have an inflection point whose coordinate is 6, 54. Alright, so based on that, let's try to sketch the picture. Alright, so here, alright, we're going to have, let's see, so we're going to have, so here's the x-axis. Alright, here is the y-axis. Alright, and here's the origin. Alright, so it looks like we're going to have to put tick marks at 3 and 6 and 9. So I'm going to put, let's say, 3 right here, and maybe 6 right here, and 9 right here. Alright, then let's put some plot points. Let's see, we're going to have a local max at 3, 108. Okay, so we have to rescale a little bit. So I'm going to put the 108 right up here. Right? Then we have 3, 108. So if you try to find the local maximum point, right? So this is going to be a local maximum point right here. Right? And the local minimum is at 9, 0. So that one's easy to find. So 9, 0 is right here. All right, and 6, 54 is an inflection point, which is actually the halfway. 54 is a halfway to 108. So it's a 54 is here. Then you can see that here there's going to be inflection point right at this point. All right. All right, so let's try to sketch a picture here. And we know that the x-intercept and the y-intercept, let's say x-intercept is 0 and 9, so it's going to go through this point here. So I'm going to go through this point. All right, so let's look at this section. All right, before 3, right? So it has to be an increasing picture, and it has to be a concave down picture, right? Then you have a local maximum there. So we know that the graph is going to look somewhat like that, right? Then between 3 and 6, so it's going to be a decreasing function graph, and it's still going to be concave down. So it actually looks like that. Right, between 6 and 9, it's still decreasing, but now it's after 6, it's concave up. So it's going to look like that, and then you have a local minimum there. Right, after that, it's increasing and the concave up. So it's going to look something like that. Right? So this is the graph of y equals x cubed minus 18x squared plus 81x. All right, see if we can find the graph which looks like that. All right, so if you look at not the first one, not the second one, all right, looks like the third one is the one that fits, and not the fourth one. All right, so let's check the answer. All right, so submit for testing. All right, it came back and looks like we got the correct picture for number 1. All right, that's it. I hope that this was clear.